Namaste everyone, welcome to my class. I am Vinod. Today we are on the concept of mass and weight. It is 9th standard physics, chapter 10, gravitation. So mass, you have been learning from your childhood that matter, whenever we define matter, matter is anything which has mass and occupies space. So based on that we are going to define mass. So mass is quantity. So the quantity of matter contained in a body. So it is the amount of matter which is present inside the body, we call it as mass. Then, is there any other definition? So when we come across Newton's laws of motion, in that we have the first law. Before coming to the first law, we have concept of inertia. In that inertia you have learnt inertia. Mass is the measure of inertia. Inertia is nothing but the property of a body to oppose any change. That is, we say it is also like resistance, opposing property. It is also due to mass. So we have mass defined in terms of matter contained in a body. Another is from Newton's first law, or you can say inertia. So from inertia, it is the measure of inertia. So it is a measure of inertia. In both, we are referring to the mass. What will be the SI unit of mass? You have learned before, it is kilogram. Kg is the SI unit of mass. So mass is a scalar quantity. Mass is always fixed, it is never going to change. So wherever you take that particular object anywhere on the earth or outside, the quantity of matter present in it or the matter in it does not change. We learn about weight. So weight is the force of attraction acting on the body. Most of the people get confused between mass and weight. So weight is nothing but the force acting on the body. If it is on the earth, so it is the force acting you can also say it as force of attraction. What attraction will be there on the earth? Gravitation. The force of attraction, the force acting on the body, so when it is on the earth, so it is towards the center of the earth. So it is the same gravitational force experienced by a body on the earth. We are going to call it as weight. So W, it is represented with W. So here when we say mass, we are going to represent with small m. Weight, capital W. Since I said it is the gravitational force experienced by the body, so it is gravitational force acting on the mass. We have two formulas. Newton's universal law of gravitation, we have G m1 m2 by d square or r square. So second formula is due to the acceleration due to gravity. So we can write the second formula here. So W is the gravitational force acting on that mass which pulls it down towards the center. So mg, acceleration due to gravity. At times we are going to use the second formula, that is the universal gravitational law also. So right now the weight of the body is equal to mg. Since it is a force, what will be the SI unit for weight? Weight will have the same unit of force, newtons. Weight of a body, since we know that acceleration due to gravity is not constant, it varies from places. On the poles it is more. So weight of a body is not constant, but it changes from place to place on the earth. Now right, if the object is not on the earth, if it is carried to the moon, there the weight of the body changes, whereas the matter contained, mass of the body does not change. On the moon, the acceleration due to gravity is very less, so the weight of the object on the moon will be very less. Okay, these two are the basic differences between mass and weight. So we will learn with some more points of differences between these two which are important for this lesson. So here I have given the differences between mass and weight, which is very important for you to learn. So first point, when we make difference between mass and weight, the definitions are, we always take the first point as definitions are the first point. Mass, it is defined as the quantity of matter contained in a body. Weight, it is the force with which the body is attracted towards the center of the earth. So attraction force, gravitational force acting on the body. So that is the difference, in the first difference with the definition. Second, mass remains constant. Wherever we take the object, the matter contained will remain constant. Whereas, since it is a force and that varies from place to place, acceleration due to gravity varies, and it also varies from planet to planet or to the satellite. So weight of the body changes from place to place. It is not constant. Mass of a body is never zero. Since we have matter contained in a body, it can never be zero. Whereas weight of a body, we have seen when we go into depths exactly at the center of the earth, the acceleration due to gravity is zero. When g is zero, we have the formula W is equal to mg. So the weight of the body at the center of the earth will be zero. Mass can never be zero, whereas weight can be zero. One example is when you take the object to the center of the earth, its weight is zero. Mass is a scalar quantity. It is represented, or it is expressed just with the magnitude, no need of direction. Whereas weight is a vector quantity. It always acts vertically downwards towards the center of the earth, so downwards. So it is a vector quantity where direction and magnitude both are required for specifying this weight. Then mass is measured in kilograms. The SI unit of mass is kg. Weight, SI unit is, since it is force, Newton, or one more unit you can write it as kg weight, or you also learn it as kg force or kg weight, which is also equal to the weight of the object. So measured, mass is measured with the help of balance. So it is a physical balance, you can say, or a beam balance. So where you are going to have two pans on both the sides. So this is a small diagram or idea of the physical balance. So weight can be measured with the help of weighing machine or spring balance. You might have seen in your physics laboratory the spring balance. So these are the instruments used for measuring mass and weight of the object. So one more important concept in gravitation. So here we have weight of an object on the surface of the moon. So when you take an object from the earth to the moon, how many times it will decrease? So when you compare the weight of the object on the moon with respect to its weight on the earth. So this is what is one of the important concept in your textbook. So in this, so I am considering an object of mass m on the surface of the earth. So one more, the same object, if it is taken to the moon, what will be its weight with respect to its weight on the earth? So we have the formula. So I am using the universal, since it is because of force of attraction, I will use universal gravitational law. Weight of the object on the earth is equal to g, mass of the earth, mass of the object, by radius of the earth square. If it is taken to the moon, the same object who will be having that, the weight of that object on the moon will be g, mass of the moon, gmm, by rm square, radius of the moon square. So now if I have to find out how many times it will reduce, what I'll do is I'll take this one as 1, this one as 2. So this is the information regarding, these are the values of mass of the earth, mass of the moon, radius of the earth, and radius of the earth and radius of the moon. So we have to substitute these values in these equations. Before doing that, I'll rearrange this. So I'm going to compare these two. Equation 2 by 1, weight of the object on the moon by weight of the object on the earth. So weight of the object on the moon, I'm going to take on the numerator G m by rm square whole divided by weight of the object on the earth G m by re square. So I'm going to division, I'm going to cross multiply this. So the numerator will be like that, only Gmm m by rm square into, so take the denominator which is there in this, so it will come to the re square, will come to the numerator, re square by G m mass of the earth into mass of the object. So universal gravitational constant, both I'm going to cancel here. So this cancellation, the mass of this gets cancelled. So I'm going to get an equation like this. So weight of the object on the moon by weight of the object on the earth equal to mass of the moon. Here mass of the moon is 7.4 into 10 power 22 into radius of the earth square. So I'm going to write like this. So 6.4 into 10 power 6 whole square by radius of the moon square, it is 1.74 into 10 power 6 whole square into mass of the earth, it is 6 into 10 power 24. So when you solve this, you are going to get W by W is 1 by 6. When you solve this entire thing, you are going to get 1 by 6. So which is equal to, weight of the object on the moon will be equal to 1 by 6 times 1 by 6 times the weight of the object on the earth. So its weight reduces by 6 times. If it is 60 kg weight, or it is 60 newtons on the earth, it will be 10 newtons on the moon. So this relation is very, very important. Weight of the object on the moon will be 1 by 6 times the weight of the object on the earth. I'll write acceleration due to gravity on the earth as 9.8 meter per second square. Acceleration due to gravity on the moon is 1.6 meter per second square. You know the formula of acceleration due to gravity. Acceleration due to gravity is small g is equal to G m by r square. That's the formula. So we need to bring or break down the equation to that small formula, G m by r square. Right now moon's weight of the object on the moon is on the numerator, so I am going to write it like that, G m by m r m square into whatever is there in the denominator. I am cross multiplying, I am going to write re square by G m. So in this I am going to cancel only m and m. Okay, then I will put this equation. So here you see once G m, this is mass of the moon by radius of the moon square. So if you consider this particular part, it is nothing but acceleration due to gravity on the moon. So I can write it as Gm. Then into, now m is cancelled, so consider only this part. So re square by Gm me. So this is Gm by r square. It is inverse of the acceleration due to gravity of the earth. So actually it is G me by re square. So since it is dividing, we are going to write it as, it is inverse of the, let us 1 by acceleration due to gravity on the earth, of the earth, acceleration due to gravity of the earth. So which is equal to, here it is Gm by Ge, 1.6 by, which is equal to 1 by 6 times. So weight of the object on the moon by weight of the object on the earth is equal to 1 by 6 times, or you can write it as weight of the object on the moon equal to 1 by 6 times the weight of the object on the earth. So using this also you can prove in a simple way. Okay, thank you so much everyone. We'll meet with the concept of pressure in solids.